If you are someone who is working as a front-end engineer, back-end engineer, full-stack engineer, mobile developer, machine learning enthusiast, whatever, the only common technology that you are definitely going to find, whether you're working with an MNC or a startup on your own project or as a freelancer, is going to be some version control system. Version control system is one of the most important skills that you need to master if you want to become a successful software engineer. In any company, any startup, you have to interact with some or the other version control system. And one of the most famous and the most widely accepted and the most widely used version control system is none other than Git. Git is an open source version control system, and it actually empowers us to not only maintain different versions of our code base, but also helps us to collaborate with a wider team. But maybe you are still not aware about what is Git. And this is something that I would highly recommend all of you to definitely learn. So I'm going to put a complete masterclass, which is going to be a 3 to 4 part series, absolutely free on this YouTube channel, where I'm going to talk about everything in Git in depth. You might be someone who is already aware about Git, then don't worry, because I am damn sure that even if you have already worked on Git, you might not be aware about few of the concepts of Git. For example, what actually happens when you actually initialize the Git repository and there is a .git folder prepared. What's actually inside that folder? Or maybe some of the advanced Git algorithms like Git rebasing, resetting, or Git re, right? These are some things that maybe you might have heard, but you might not be having very in-depth knowledge about, right? A lot of times, a lot of people say that, oh, I made a wrong commit. How do I revert it? Should I do git reset soft or should I do git reset hard? Or is there any other mode as well? All of these things we are going to talk about in this masterclass. This is going to be a long one, I would say, because everything from scratch we are going to discuss. It's going to be an absolutely free lecture, and this is going to come in 3 parts in 1 or 2 weeks, most probably. And the first part is going to be the continuation of this particular video only. So in this one, you can actually start learning what is Git, how you can set up Git, and how you can actually get started with it with a lot of advanced concepts around Git. Git is something that is one of my favorite topics to teach, and I believe that you guys are going to definitely like the lecture. And I'm going to make sure that this is the only Git series that you need to watch. So, what are you waiting for? Let's just quickly dive in and start our journey with Git. But before that, if you have not yet subscribed to the channel, do consider subscribing to the channel. We are going to bring some awesome content on this particular channel. Also, we have launched our new website, AlgoCamp.io. Do check it out. There are a lot of bunch of courses that we are going to release. So do check it out. And without any further delay, let's just start and let's take a very in-depth dive around Git. So if you have not checked AlgoCamp.io yet, I would highly recommend you guys to check out AlgoCamp.io. You can see we have launched a bunch of new courses. For example, there's a new Java plus DSA plus backend in Java as well as a system design course. This is a hybrid course that we are launching where we are going to cover everything in core Java from the very scratch, like if else, loops, functions, recursion, all the data structures and algorithms like binary search, sorting, searching, dynamic programming, linked lists, stacks, queues, binary trees, everything end to end. You can see even we are covering things like segment trees, graph algorithms, etc. And then we are going to start covering things around system design, where we are going to cover a bunch of things around DBMS, computer networks. We will talk about how you can actually do low-level designing around different design patterns like singleton design pattern, builder pattern, prototype pattern, etc. We are also going to learn a bunch of high level design stuff where we are going to cover topics around how you can design a URL shortener or how you can design a streaming service like Hotstar or maybe something like Uber, along with a lot of important terminologies of HLD. And the most highlighted part is the backend development with Spring Boot. This Java course is also going to teach you how you can do backend development in Spring Boot, right? A whole end-to-end project we are going to make, right? So me along with Ria is going to take this course. This is going to be a 60% live course, 40% recorded, because there is a hell lot of things that we are going to cover in this particular course, right? So you can definitely check out algocamp.io and you can check out the corresponding course. I'll link the course in the description section, so don't forget to check it out. And Without any further delay, let's just move back to our lecture on Git. Now, a lot of times you might have used applications like Android Play Store or Apple App Store, right? And you might have downloaded a bunch of applications up till now, and you might have used a lot of application, uninstalled them, reinstalled them. You must have played with a bunch of softwares for a very long period of time, starting from very small operating systems you must have downloaded, and now using Play Store and App Store, you download relatively smaller apps which are technically very high impacting as well, right? Like, to be very honest, the overall app development industry is very huge. But I'm not here to talk about how to do app development or something, but instead I'm going to actually talk about something which is even more fundamental, and something which you might have even noticed a lot of times in different applications whenever you start downloading it from these platforms. Now, the thing that I'm talking about is the version. For example, here I have opened Amazon Prime Video on the Apple App Store for my Mac, and here you can see there is a version written. There is a version written, right, in the Apple App Store. And this version you might see with a lot of applications. Sometimes few applications most probably might be able to hide it as well, right? For example, let's see, um, let's search for some Adobe applications or some PDF readers maybe. Okay. Sometimes you are able to see, sometimes you are not. You can just check. For example, for this one it is not visible, or here we have version. So a lot of time version history is also available. So what is this version history, right? What is this version history that we have with a lot of applications? Now, when an application is actually built up, then it's not completed in one go, right? For example, if you are going to start your own startup and you are going to make the next big Book My Show, then of course you won't be able to code all of the features of Book My Show in one go. And technically, you don't even need it. You need to first of all launch the MVP, that is the minimum viable product. Once the MVP is there, then you start making improvements and you release the relative stable version which has even more amount of features, because a lot of market fit and everything you have to check. That's why when you actually launch your applications, it's not mandatory that you put all of the features in one go and that's it. That's the application is done. But actually, this application development or the software development life cycle is an iterative process. Every week, every 2 weeks, you try to add new features to the application. Maybe sometimes it takes more time, sometimes it takes less time, depending on the complexity of the feature, right? Now, what happens is whenever you complete one milestone, like multiple features together make one milestone, right? So whenever you complete one milestone, you try to release all of these features which are part of one clubbed milestone together, and that you refer as the new version of the application. For example, when Amazon Prime Video will release some more stable bug fixes and performance improvement and a few features here and there, they will definitely change this version. So what version actually represents? You can even check the version history. You can see what happened in every version. See how many different releases they have done since the last 6 months, right? Even they had a release 3 days ago, and now they have a released even 19 hours ago. So they have a very frequent release, right? So what actually is the meaning of this version? So in every version, you have some set of new features, some fixes, some improvements, some features are deprecated, but overall you make your code change, right? Some code change exists due to which you add a feature or maybe you remove a feature and so on and so forth. Now, to write a piece of code, of course, there is a lot of languages, frameworks, tools available using which you can make these applications. But think about something like Amazon Prime Video. This application is so big and they have to release so frequent versions that managing the versions might become extremely hard. The first question that might come to your mind is, why do you even want to manage the version? Let's say you made a release, you clubbed a bunch of features and you made a release, but that release was unstable due to some features. The first step, if it's a catastrophic failure, the first step would be to roll back to the last stable version, to somehow make your changes go away from the production application so that it can go back to the state where everything was working fine. So you might have to hop on and hop off between multiple versions.
Apart from that, let's say some features were deprecated in a few version, and then you want to again put them in place and start working on them again. You might have to do that. And this is not the only scenario for versions. Now, any piece of software is not just made by one person or two-person. It's generally a good bunch of team that actually contributes to a piece of software. Now, how do you manage this collaborative coding environment? Because it's not like I will code one page of the application, you will code the next page of the application, and I'll share you all of my code over an email, and then you will be able to test. No, it's not like that. So the first problem that we have in our hand is managing versions. Second problem that we have in our hand is actually maintaining a collaborative environment where multiple people can club up together and actually start contributing to the code. That's why we have a bunch of tools that helps us to do version management as well as collaborative coding practices also they actually provide, right? These tools are so important that if I list the top 3 skills that you need to know before becoming the one software engineer, then I will definitely list this skill or this tool at the topmost priority. Because you might change companies, you might go to different tech stacks, different products, but 99% of the time you are going to use something same, right? Something similar is going to be used everywhere, right? And that's where we are going to introduce something called as Git. What is Git? What is GitHub? Why do you use it? What all companies are using it? Have I ever used it? All of these things we are going to discuss. But before that, I hope the problem of version control, what is a version? Why do you need a version control management system? How, why collaborative coding environment is important? I believe all of these points are clear to everyone. Now, what is Git? What is Git? So first of all, the simplest definition of Git is version control system. It is a tool or it is a piece of software using which you can manage multiple versions of a piece of code. Now just think about it. If there were two problems that we were wanting, but that we were thinking to tackle. First problem was how can you manage multiple versions? That we are saying that Git is a version control management system. Second problem was collaborative coding environment. Now just think about it. Let's say you and your friend are sitting together and building a project. Your friend built a new feature, you built a new feature, then your friend built two new features and so on. Then technically with every feature, you're technically creating a one very new small version of the app only, right? Whenever you add a new feature to the app, it's technically a new version on a very small scale, right? So technically having a version control system might be able to solve both of the problems for us. Because what will version control system do? Version control system will be helping us to manage different versions of the corresponding application. Whatever piece of code you are building, it helps us to manage different versions out of it, right? Apart from that, Git is a absolutely highly scalable version control system. As I said, 99% of the industry, if you take a even more realistic figure and more optimistic, maybe 95% of the industry is relied on Git, right? If you see, it was released in 2005, and since then there is no turning back. And it was built by the same person who was responsible for creating one of the biggest operating systems. I guess you already know about it. Right. So Torvalds was also behind the implementations and release of Git. Right. So Git is it's a free open source version control system. So anyone anywhere can use it. You don't need anything else, or you don't need to pay someone in order to use Git. It's absolutely free, it's open source, and it is filled with a lot of features. Now, Git is not a programming language for which you need to learn the syntax and everything. Git is like a tool. So if I think about any tool, for example, you must have used Microsoft PowerPoint. Now you don't care about how PowerPoint is made, or you don't care about who must have coded PowerPoint, or if I have to code something like PowerPoint, how you will do it. Instead, PowerPoint is for making presentations. What do you do? It's a tool. So you see all of the options of PowerPoint, and whatever is your requirement, based on that, you know how to use an option. For example, if I ask you to insert a new slide in PowerPoint, then you should know the steps to use the tool such that you can add a new slide to the PowerPoint. Similar thing happens with Git. Git is more about knowing how to use the tool rather than thinking about how you will make it. But here we don't just cover the surface. It's like if you know this much part that how to use the tool, it's going to be more than sufficient. But still, it becomes interesting to understand how Git internally works. So it's like I'm going to discuss about how Git internals work, but it is definitely not mandatory to know how Git internals work. Nobody is going to ask you this in any interview. 99% of the time, this piece of information is not going to be relevant for your daily software engineering purpose. But knowing how internally things are working helps to understand a lot of architecture about the technology, and I believe this practice is pretty cool. That's why I will take a deep dive around how internally Git manages everything for you. Right, we will talk about that. But first of all, if you want to read more about Git, and if you want to download Git for your operating system, just Google Git. You will get git-scm.com. Pretty simple website. Whatever is your operating system, based on your operating system, you will be getting a download prompt. Just download it and set it up. It's a very straightforward setup that you have, right? And if you want, you can just pretty easily go on YouTube. So you can search about, let's say, how to install Git on Windows 10, for example. So you will get a lot of video tutorials also on how to install Git on Windows. You can refer any of these video tutorials, or maybe you can just write in front of it Medium. You will get a bunch of Medium articles on how you can install Git on Windows, right? So anything you can use. It's a very straightforward process, be it Windows, be it Linux, be it Mac, right? And as I said, it's just a tool. So just like Microsoft Office, it's again a tool. So the installation steps are going to be relatively straightforward, right? Now we are going to talk about a lot of things around Git, that what Git offers, what you can do with Git, and what is GitHub. We are going to talk about all of this, but I believe the basic agenda around what is Git is clear to everyone. What is GitHub? Now, Git and GitHub, like a lot of people are very much confused about, is there a difference between Git? Is there a difference between GitHub, and so on? So first of all, let me tell you, Git is a version control system. So just like Git, there are multiple other version control system also. For example, Mercurial. Mercurial is a direct competitor, you can say, for Git. It's also a version control system. Like, so you can compare Mercurial and Git. It's like comparing apple to an apple. Now, what is GitHub? GitHub is absolutely different than Git. This is something that you need to understand very carefully. Okay. GitHub is an online tool for collaboration on open source or closed source softwares, right? GitHub doesn't do version control for you. Technically, internally, it might be using Git. If you just directly, like, you can create an online folder directly there. But overall, you can say it's an online tool which harness the power of Git or similar version control systems to actually prepare a collaborative environment for an open source or a closed source or piece of software, right? So Git is the actual version control system software or the tool. GitHub is made on top of it, right? GitHub harnesses the power of the version control systems and gives you kind of like a GUI interface to do a lot of things, and helps us to keep our projects online over the internet, so that everyone don't have to, like, if somebody, two people want to share a bunch of code, they don't have to be on a private network. If everyone is on internet, they can actually go and fetch the code, they can go and upload the code, and the version control will happen exactly just like how things would have done if we were using Git, right? Because underlying it is just using Git, or maybe it might be using power of other version control systems also. But overall, GitHub is an online platform, right? So you can see it is designed for collaboration. On GitHub, what you can do, you can upload your projects or you can upload your piece of code. Multiple people can contribute directly to that piece of code, because underlying it is what? Just Git, right? And you will be able to manage versions. You will get a very good, clean UI interface to see all of the versions of your particular application, and it provides some more features. Not just this, some more features. For example, you can create issues. For example, what is issues? Let's say you want to build 10 features in your application and there are 5 bugs. You can list everything like an issue, right? So you can create issues, that what you have to do, what is the priority and everything, right? It gives you an interface to actually, I would say, create feature requests. Like, let's say you coded a feature and then you can raise a request directly over GitHub. So a lot of online collaborative tooling, it helps us and it provides us. And there are similar platforms like GitHub. Like, GitHub is not the only platform that you have. There is something called as GitLab. If you want, you can use it. There is something called as Bitbucket, and there will be something definitely even more than this, right? You have Bitbucket, you have GitLab, you have GitHub. Multiple tools exist, right? Generally, people learn GitHub because it's sufficient. Most of the open source piece of software you will definitely find somewhere on GitHub only. Like, there might be 10% chance that it might be available on any other platform like GitLab, Bitbucket, or maybe something else. But mostly we find most of the things on GitHub only. It's pretty cool, and technically it's free. At least as a personal use, it's most of the features are free. So definitely it's worth exploring GitHub. But I believe the basic difference between Git and GitHub is clear to everyone. Now, to get better understanding of how exactly GitHub works, you can see this is my profile on GitHub. So you can open any piece of software. For example, this is a piece of software. This is not owned by me. You can see this is owned by Berkman Center. What is Berkman Center? Berkman Center is actually a division in Harvard University, right? So this piece of software, that is Question 2 Lab, is actually owned by Berkman Center. Now you can actually see what all step-by-step features we actually developed here, right? Every feature will be having this commit ID. I'll talk about what is commit and everything, but you can see what step-by-step progression we did, right? And there can be parallel developments that might also go on. For example, there is a concept of branches. So the same snapshot of the code might be available parallelly at multiple branches, and you can make changes to one branch that is absolutely isolated from other branch. For example, it's kind of like having parallel realities for your own piece of code. So for example, there is a dev branch, there is master branch. I'll talk about all branching stuff and everything. You can see what changes were there in the master branch, what changes were there in the dev branch. Everything is actually present there. And because, as I said, for both open source and closed source, every piece of software you can use. So you can see this is an open source piece of software, so you can actually go and read the code as well. Now the best part is, underlying what you have to do is, on your local machine you have to build up the code and you just directly upload it on GitHub. Rest everything Git and GitHub manages for you, right? So it's pretty powerful, right? You can have all of the piece of code directly written inside here. Somebody can come and actually read that code in case if it is open source, or if even if it is closed source, then technically they can, if they are your collaborator, then they can actually read it, right? And this is something that is owned by someone else, and I was still able to contribute to it, all thanks to Git and GitHub, right? You can even have your own set of repositories, right? For example, this is my competitive programming repository. I used to maintain it 2-3 years back. Now I'm not sure last when I added some code to it, but you can see a bunch of coding implementations. You will see a lot of codes that I've uploaded here, right? You can see all of this stuff. So you can just not only create your own repositories. If you don't understand repository, you can say it's a project folder kind of simple terms. It's a project folder kind of a thing. So if you don't want to maintain just your own repository, you can contribute to someone else's repository. For example, if you want to see the code base of Android, right? So Android operating system, I believe everybody knows, right? So this is the official repository of Android, right? Of course, a lot of things might be maintained by Google, and you can go and start reading about different projects that Android actually maintains, right? Inside this, you will also find the actual Android open source repository that has all the code for the Android operating system. Similar to that, you can see a lot of famous JavaScript libraries. For example, React, you can check on GitHub, right? Then what's the source code of React? Of course, React is maintained by Facebook. So you can see Facebook is the org, and then this is the actual React project. So you can, if you have that much amount of capacity, you can go and actually start reading what code they have, you will see all of the different details, all of the contributor details, everything you will actually see directly here. So this is how things might look like at GitHub, right? You have to create an account. It's absolutely free. You just need an email to create an account at GitHub, and you just need to download Git, and you are ready to start for whatever you want to do. Now, in order to check whether you have installed Git properly or not, you need to open your terminal. If you're on Linux or Mac, just open your terminal. If you're on Windows, open Git Bash. Okay, and just type Git minus minus version. I believe this should show you the version. If it shows you some version, you are ready to go. Generally, some 2.x version should be good, right? Then there is a command called as git config minus minus list. Okay, if you will run this command, then you will get something called as your user email, that what email you have, and there will be some credential helper, right? Now, what is this git config? So once you actually download Git, it's not just done and dusted there. You need to configure your GitHub account. If you want to connect your GitHub account to your local Git tool, then you need to actually add a bunch of configs in order to set it up, right? So how to set it up? You can just easily Google it. So git config setup, okay, for GitHub. You'll get a bunch of articles configuring Git and GitHub desktop. Also, there is a software called as GitHub desktop that gives you a lot of GUI interface for doing a lot of Git command stuff. I generally don't recommend it because you might not be able to use it everywhere. Okay, so if you go on GitHub docs and go here, setup Git, you can read this doc, right? It mentions everything step by step, that you need to first of all download the latest version of Git. Then you need to set a bunch of username, then set your commit email address, then how can you authenticate, how to connect over SSH. A lot of steps are written here. Read it thoroughly. This is the link, right in front of you. This is the link. Read it thoroughly so that you can set it up yourself, right? We are not going to go into a lot of setup stuff, like how to set up, because every operating system is different. Every student might be having a different operating system, and even if you have a same operating system, you might be having different versions of it. So maybe something that works for me might not work for you, so you have to struggle a bit around in installation. But again, as I said, two things are ready for your service. One is a lot of YouTube tutorials where a lot of people have told about how to set up Git and command line and the configs of Git in your system in different operating systems, or maybe a bunch of good Medium articles. Otherwise, even this official article from GitHub is going to be extremely helpful. So make sure you set up your config well, and once you set up, you will get some similar email ID or maybe password also written there. It's in Mac, it shows OSX chain and everything, but you will get a similar kind of a prompt there. So make sure you get that. Once you have it, then your Git and GitHub account are going to be connected. You can start uploading your code to GitHub directly. If you don't do this Git config setup, no problem. You still will be able to use all of the features of Git, but you won't be able to upload it on GitHub. That can be one problematic scenario. Now, let's say if you are making a project, right, and you want to enable that project to be controlled by a version control system like Git. Whatever we are going to discuss is going to be everything about Git. So it's going to be a very easy step. So Git is a very easy to use tool. It has a bunch of commands. You don't even need to remember all of the commands. Whenever you have to do it, you can Google it. You'll find a lot of stuff, right? So all you have to do is just execute a bunch of commands and it will execute a bunch of things for you, right? So let's say I'll make a new folder. Okay, I'll make a new folder, Git demo app. Okay, and let's say I go inside that folder. Okay, so I am inside this folder. You can make this folder using the GUI interface also, but whatever demonstration I'm going to show you for Git is going to be using the command line interface, because I believe it is more important to understand the command line interface. A lot of times when you have to deal with production servers, then you don't get a GUI interface there. you might have to deal with a lot of command line stuff. So if you have a habit of it, it's good. But there are tools like GitHub Desktop. I can just quickly show you that. GitHub Desktop, using which you can do most of the stuff of Git using a GUI interface like this, right? So maybe if you want, you can use it. Okay, but generally, I believe using like command line is a bit better. Okay, so now let's say this is a project that I want to enable with Git, and let's say inside this project I have a bunch of files, touch readme.txt. Okay, so if you will see, now I have a new file inside it. Okay, this command actually creates a new file and I have a new empty file inside it. If you want to see what is the content of the file, you can just do cat.txt and you can see everything is empty. Okay, cool. Now if you want to enable this project, for example, this project will be later getting a lot of files. For example, if you want to enable this project to be used using Git, there is a very easy command called as git init. When you do git init, what actually Git does is Git creates a new folder called as .git. It creates a new folder called as .git inside your repository or inside your project. So the moment I press enter, it gives a bunch of hint, da da da. But the main thing that we have here is initialized an empty Git repository inside this folder. And you can see it created a .git folder. If you do ls, you won't be able to see the .git folder. Why? Because it's a hidden folder. If you do ls minus a, now you will see a .git folder, right? So it's a hidden folder. The moment you do git init, you actually can create this folder, right? If you want to see the content of the folder, you can just go inside the folder, right? And you can do ls. There is a bunch of stuff that we are going to discuss what is the meaning of each and every stuff here, but there is a lot of things that Git does once you initialize your project, right? Let me open VS Code here. You can see we have just one file here, nothing much. The .git folder won't be even visible in your VS Code or most of the text editor or whatever IDE you use. But internally, it creates a .git folder which has a lot of stuff. It has a lot of files. It has a lot of folders. Everything we will talk about, and everything is very relevant for Git to maintain different versions in the most efficient manner as possible. Definitely, Git doesn't create copy of the same piece of code. Git is very smart. It's very efficient. So all of these things we are going to discuss when we will start discussing about the .git folder, right? But for the timing, you can see I have this basic file and the project is now ready to be used with the version control system of Git because it is now powered by Git. So I hope this basic command is clear to everyone. Inside this readme, I'll just try to mention this command. Most of the commands I'll try to mention because we need to do a lot of changes. So git init creates a new, or I would say powers your folder to be managed by Git and initializes a new empty repository. Okay, initializes a new empty repository. It also creates a .git folder that has all the relevant logic to manage versions of your project. Okay, this is something that git init actually does. So I hope the basic logic around the first command git init is clear to everyone. Now let's say you powered your project with Git. Now let's say you don't want it, right? Or let's say you want to reinitialize the project. So if you will write the command git init again, then it will say reinitialized existing Git repository. So it will refresh the existing Git repository. But let's say if you want to just remove it from Git, like now you don't want to manage it from Git, all you have to do is just delete this .git folder. Now you can delete this .git folder from GUI by listing all the hidden folders also, or you can just do rm. If you are using a Linux system, you can do rm -rf .git. The moment you do it, you can see .git is gone. If .git is gone, then no one is managing your Git repository or your project using Git. If you want to reinitialize it, you can just do git init. So that .git folder is actually the powerhouse how Git actually does most of the things. So if you delete it, everything is gone. That can be one useful way if you want to just get out of it. Now let's say once the Git repository is made, let's see how it actually looks like. Let me open a new terminal, right? And let me just redirect myself to the repository. This is Git demo app much. Okay, cool. Now you can see once we have enabled everything with Git, then if you will do ls minus l, sorry, ls minus a, you are going to see a hidden folder .git where everything actually get actually managed. Right, we are going to also take a deep dive around the .git folder, actually what happens behind the scenes for it. Okay, now there is a command called as git status or git status, whatever you pronounce it as, git status. The moment you do git status, you actually see a bunch of data coming up on your screen, right? You get a line saying that this is on branch master. So first question that might come to your mind is, what is a branch? Okay, then the next line says no commits yet. The next question should come to your mind is, what is commit? And then it says untracked files, readme.txt and new.txt, right? Use git add and the file to include in what will be committed, and nothing added to commit but untracked files are present. So bunch of data we are actually getting, and this actually represents some of the most crucial components that actually exist inside Git. So let's start one by one talking about it. So when you actually work on a project and you have enabled the version control system of that project to be managed using Git, so technically, and if I say theoretically, if you imagine, there are three areas in which your file changes can actually reside. Okay, one area is going to be the working area. Another area is going to be the staged area or staging area, whatever you call it. Another one is repository area, right? So technically, any file change that you actually do might lie in one of the three areas. First area is the working area, staged area, and repository area. Okay. Now let's try to understand when a file is in what stage. Okay. So what is working area? Currently, this readme.txt and new.txt is in your working area. Why it's your working area? Because currently, whatever changes you do, these changes are not getting tracked by Git. Let's say I start changing the readme.txt. Let's say I maybe add one more line to it, right? And save it. So currently, this change will not be actually tracked by Git. If you do git status, see it still says the same. You have readme.txt as an untracked file. So working area is the area where you actually most probably created a new file or you started creating a new change, but you have not started tracking it using Git. When you say tracking it using Git, that means Git won't know that these changes may or may not go to the next version that you are actually going to prepare for. So if you want to do a definition around working area, okay, and definitions, okay, I'll also manage definitions using this. Okay, so what's the working area? There can be a bunch of files that are not currently handled by Git. Now, what do I mean when I say not currently handled by Git? It means that changes done or to be done in those files are not managed by Git yet, right? A file which is in working area, right, is considered to be not in the staging area, right? So if the file is in a working area, then that means the file is not in the staging area, right? When we do git status and we see a bunch of untracked files, for example, if you see here a bunch of untracked files, right, then these are actually called to be in the working area, right? So if you have to see what all files are in your working area and they are currently not tracked by Git, now the whole repository is going to manage every file in the version control system Git, but you have to now specifically mention that, okay, I want you to start tracking this file, I want Git you to start tracking this file. You have to manually mention that. Git won't automatically start managing every file, because maybe you are making some log files or maybe some temporary files that you technically are doing for temporary purpose. You don't want Git to start managing every single file that you want or that you made because you just made it in the same repository. Because maybe you're doing some temporary work, maybe you're doing some debugging, you're trying some code, but that's not going to actually get pushed. In that cases, this kind of feature helps that any new file that you're going to make, it's going to be an untracked file, right? And that file is going to be expected to be in the working area. So these two files are currently in the working area. Now, the second area of reference that we have to talk about is the staging area. Okay, staging area or staged area. Okay, now what is stage area? Staging area is going to tell you that what all files are going to be part of the next version. What all files are going to be part of the next version that we will create. Okay, so once you add a file in the staging area, that file is bound to be going to the next version that you are going to create, right? This staging area is the place where Git knows what changes will be done from the last version to the next version, right? So what all changes you are going to do actually in the last version to the next version, you can actually, or Git can actually understand that using staging area. So by default, you can see I made these two files, readme.txt and new.txt. They are by default in the working area. Now, how can I move them to staging area? See, they are also already mentioning the command. They say use git add and the file name to include in what will be committed. And see, what is the definition of staging area? I said it is going to be the part of the next version that we will create, and it will know what are the changes from the last version to the next version. So what new version you are going to create, if you want to make the current file to be part of it, you can do git add. So by doing git add and the file name, for example, readme.txt, you are going to move your set of untracked files from the working area to the staging area the moment I enter it. So let's say git status, and now you can see readme is now no more an untracked file, right? So you get a new prompt here, changes to be committed. Commit means a new version. We'll talk more about commit, but for the time you can understand that commit means a version. So when it says changes to be committed means that we are going to say that in the upcoming version we are going to add it. We have not yet added it in the version. right? It's not currently gone in the corresponding version, but we are going to move it to the corresponding version. Okay. And it is now mentioning you another command, git rm minus cache this file to unstage. If this command is to unstage the corresponding file, that means currently it is in what area? It's in the staging area. So if you want to unstage it, or you can say if you want to remove it from staging area, you can do git rm. So you do git rm minus cached. Minus cache is to, I guess, just make sure that git doesn't cache the copy of the file or something, right? And you do readme.txt the moment you enter it, and now you do git status. See, now this prompt is no more coming because there is nothing in the staging area, and now every file is again untracked. So this is how you can move a file from the working area to the staging area, and from the staging area back to the working area. These are two of the most crucial components of the actual state of a code change or a file change that actually happens inside Git. Now the third area that we have is actually the repository. That's actually similar to the repository wherever we are using the word the repository area. The repository area. Okay. What is this? This area actually contains the details of all your previous registered versions. So whenever we register a version, it is going to store the data of all of it, right? And the files in this area, Git already manages them and knows their version history, right? And knows their version history. So how can you add something in the repository area? Now, the first thing that you need to keep in mind is that we are saying that this area actually contains the details of your all previous registered versions. When you say all previous registered versions, then technically you need to first of all register a version. How do you register a version? Let me tell you. Let's start writing details about a bunch of commands. So when you do git add and a file, this actually moves file from working area to staging area, right? Then you can do 6 git rm file, and you can even do minus cached. Okay, this moves file back from staging area to working area. Okay, now let's say you want to move the file from staging area to a repository area. That means you need to actually create a version. Now in Git, versions are actually managed using commits. You can, for your starters, until unless we actually go inside the .git repository, .git folder and actually see what is actually happening behind the scenes, you can say that commit is like one version. One Git commit is like one version, right? One version that you have actually made, right? This is something that you can try to understand with respect to it. Okay. When you actually say commit, let me start writing about it. Okay. Meaning of commit. Commit is a particular version of the project. Okay. It captures a snapshot of the project's staged changes, right? Because as I said, the details that are in the staging areas are going to be part of the next version. So when you actually commit them, it actually creates a snapshot of that stage changes and create a version out of it, and creates a version out of it. Okay. You can say that whenever you create a commit, then you have actually registered a bunch of changes with Git. So now they are safe. You'll be able to see them in the history. If you make any change, you will be able to roll back to them. All of these things you will be able to do. And how you can actually do that? You can use the command git commit. Okay. You can use the command git commit to actually registers staging changes to a commit, right? And if it goes to a commit, then technically it's part of the repository area. So let's see. Currently, we have nothing in the staging area, right? So let's do this. Git add readme.txt. If you do git status, then technically you can see this is now the part of staging area. Readme.txt is part of staging area. Now if you do git commit, the moment you just do git commit and press enter, now it is going to show a prompt in front of you. It's kind of like a terminal based text editor that has been opened in front of you, right? So what it expects you to do is it expects you to actually add a particular message, right? So this is actually the Vim editor. This is actually the Vim editor. If you don't know how Vim editor works, you can actually Google about it, right? So what happens with Vim editor is if you want to make some changes to the Vim editor, you have to first press the key I. It will start making changes to the insert mode, and now you can add something. This is my first commit. Now it expects you to write a commit message. You can even escape it, but it's generally recommended to do that. Now if you want to save this change, all you have to do is press escape, then press colon. You can see a colon coming up here. You can see a colon coming up, and then press WQ. See, escape colon WQ, and now press enter. You can see it said one file change, 26 insertion, create mode this, readme.txt. So technically we have registered one commit. Now how can you see all of your commit? You can do git log. If you do git log, you will be able to see all of your commits. So see, this is the commit message that I added, right? This is my first commit. And who is the author of the commit? Sanket Singh is the author of the commit. What is the date of the commit? This is the date of the commit. And because, as I said, every commit is technically one version, so every commit has a unique hash. This unique hash is technically very important in order to understand how exactly internally Git handles everything. But for the time being, you can assume that every commit will be having a unique number, commit number or commit ID, using which we will be able to also relocate. Like let's say we have 10 commits, so that means we have 10 versions, and we want to come back to a particular commit. That's what we will be able to do. Now there is something called as this head. I'm going to talk about this head also. This technically represents which current commit of which branch we are at, but I'll talk more about head. But for the timing, you can see the moment you do git log, you will be able to see all of the commits. So the next command that is important is going to be git log. List downs all the possible commits, all the commits of the repository. Okay, that's what git log do. If you want to exit out of git log, all you have to do is just press Q and you will be exited out of it. If you want to exit out of git log from, press Q. That's it. That's how you will be able to get out of the git log. Now one very interesting thing that I would like to show you. I created this commit, and after creating this commit, I have added technically this 5 lines. Can you see VS Code also tracks? The moment you see something is green here, that means all of these lines have been added. If I will remove a line, so Git will make that part red, that some part has been removed, right? So from your last version, currently you have added some lines or maybe you have removed some lines. All of these things you can actually see. Now the moment you actually added some more piece of code, let's see what happens. If you do git status, now technically, because readme was already added to the staging area and that part of the staging area is now committed, you can see when you again make changes to readme.txt, it is not untracked. See, it's already in the staging area. These are the changes which will be committed. So once you put the things in staging area and you commit it, they're always going to be, whenever you make a change, those changes are already going to be in the staging area, because the moment you put anything in the repository, what did I say? Git manages them. So if Git has already started managing a file, every file change that you are going to do between 2 commits, Git is going to manage that. But you can see this new.txt is still not managed by Git, so it is still getting shown as untracked. If you will remove all of your changes, for example, just for a moment, if I remove all of my changes, now you can see nothing is there in the change. If you do git status, now you can see changes are gone. Changes to be committed are gone because there are no new changes. If you bring back those changes and do git status, you can see this prompt again comes up. So now once you have started tracking a file, now this is a trackable file. Once you have started tracking the file in the repository, any code change that you are going to do or any data change that you are going to do in the file is actually going to be available with Git, and Git will be able to manage it. If you want to technically remove it, you can again see there is a bunch of commands that are actually coming up, right? Now I would like to throw some light on this command, git restore. Now what happens with git restore? Currently you can see it is going to discard all the changes that you have done. So currently these are the 5-line changes. If I will do git restore readme.txt and press enter, can you see my changes are gone? All of the changes are gone, right? So let's say you did some work and that's a dirty piece of code. You don't want this to be committed. What you can do git restore. Let me bring that work again. See, now again I brought it up. If you do git status, again it is showing. Now I thought that, oh, this piece of code is not good. I don't want to keep it. I don't want to commit it. When I say I don't want to keep it, I mean I don't want to commit it in the next version. I can do git restore. What git restore is going to do? Git restore is going to delete everything which is in the staging area but not yet committed. So if you do git restore, see it got deleted. So everything that was in the staging area has been now deleted and it's now no more going to be committed. Let me bring it back. So that's what git restore does. So let me add it. Git restore and a file. Okay. So what it does is it remove all file changes from the staging area to be committed. Right. This can be useful if we did some dirty piece of code and now no more want it. Instead of deleting every change line by line, we can restore it. Restore it, or you can say restore last clean version. Okay. So generally what people do is, if let's say they have made any code change and now they don't want it, so they manually go and delete everything. If you are managing things by Git, you can just do git restore of the file. It will give you the last committed version of the file, which is technically more clean, and all of your changes will be gone in one shot instead of you going to every file and then removing it. Now one question that can come to your mind is that if you do git status, currently we have this in the staging area, this is going to be committed. Now there is a slight difference between how things work with an already committed file. Now because this is an already committed file, this file readme.txt is already committed. Whatever changes you do, those changes are also, you can see, in a working directory only. So the changes are in the working area only. But the moment you do git add on readme.txt, again, now you do git status, you can see they are back on the staging area. So whenever you make a change to a already committed file, those changes are also going to be in the working directory. But until or unless you add the file again, those changes are not going to go to the stage, right? Now if you do git restore here on readme.txt, you can see nothing has been dropped because now you actually brought it from working area to the staging area. If you want to remove it from the staging area, let me just copy this so that we don't lose it. You can do git restore -- staged and then mention the file name readme.txt. Now let's see what happens. You can see now you are back. See this green symbol? That means you are back in the working directory. See git status? You are back in the working directory. And now you can do git restore readme.txt. You can see those changes are gone. So that's what the meaning is. Let me actually draw it and also show you. So let's say you are having a file, and this file is in the repository. That means this is already committed. Okay. Now you added a new piece of code here. New additions you did. Right. New additions you did. So when you will do git status, although the file is committed, but these changes in git status will be in working area. Right. So if you do git restore here, git restore file name, these changes will be removed because these are currently in the working area. These have not gone to the staging area. The moment you do git add file name again, then whatever new changes the file is bringing, some changes are already committed. Whatever new changes the file is bringing, those changes are going to move to staging area. Now in the staging area, if you will do git restore the file, it will not directly work. If you want to restore whatever changes you have added in the staging area back to the working area, you need to do git restore minus minus staged and then mention the file name. What this command will do, this will bring this file back in the working area, and then you can do git restore to make it revert it altogether. Otherwise, here you can do git commit. Okay, here you can do git commit. This is the difference between moving a new file from working area to the staging area and moving a change of the file from working area to the staging area. So whenever a new change comes up, it is going to be in the working directory. Once you do git add, it is going to be in the staging area where it is going to be committed in the next version until or unless you remove it from the staging area. And then you can play with the restoration cycle to maybe remove it from the staging area back to the working area and so on. Now let's see. So we have these changes. Let's add them to the staging area. Git add readme.txt, and I'll do git status. You can see these are in the staging area. Okay. Now we will do git commit. Okay. We'll create another version. So last version was already there. I'll do git commit. You can see it again opened the prompt. I'll press I because this is using Vim editor in my system. This is my second commit. Escape :WQ. Press enter, and another commit has been registered. You can do git log. See, now there are two commits. First commit and the next commit. That is the latest one. Press Q to exit. Now let's make a few more changes. So let's say I'll add one more command, 11. Git restore minus minus staged file name. It removes file from staging or file changes from staging area to the working area. Okay, cool. Now if you do git status, currently you can see again it's in the working area. So if you will just do, let me just copy this. If you will just do git restore readme.txt, because working area, whatever changes are in there in your working area, those are not going to be the part of the commit. Only those changes become the part of the commit that are in the staging area. So now if you do git restore, everything is going to be gone to the last commit. So our last commit was the second commit. Till that point we had 10 pointers in the file, right? So you can see the last committed version of the file, we have restored that, which is the cleanest version. So as I said, if you are making some changes, now you don't want it, you just do git restore because currently you are just in the working directory. But maybe you did git add. Now you can see the changes are here. I do git status, changes are here. I do git add again. The moment I do git add, now technically these changes have moved from working area to the staging area. Now if you will do git restore, you can see nothing happened because there is nothing dirty piece of code which is in the working area. Generally, whatever is in the working area, it's a bit, you can refer it as a dirty piece of code that has not been staged yet. But currently line number 11 is now in the staging area. That means it's on the verge of getting committed to the next version. So if you want to remove your last stage or the last changes that you added in the stage, then what you can do? Let's see. So I'll add one more line. Okay. So this only works if changes are in your staging area. Okay, let's see. Now you can see again there will be a dirty working copy, and I do add again. Now before you actually move forward, now see, for readme.txt, there are some changes which are not yet part of the next commit but will be the part of the next commit. And what are those changes? Line number 11. Line number 11 is the code change which is in the staging area and it is going to be the part of the next commit. But there are some more changes which are currently in the working area. They are not in the staging area, and those are line number 36. So now technically, if you do git restore minus minus staged readme.txt, now what will happen? See, your last staging area changes also came to the working directory. So now this line number 36 is also in the working area, and this point number 11 is also in the working area. You can see git status. Now you can see only you are getting working area and untracked files. You are not getting the staging area. This is the prompt for the staging area. This is what you do. So when you do git restore directly, you move from working copy to absolutely clean copy. You will just lose all of your changes. But if you have made the changes to go from the working area to the staging area, then only those changes can be reverted back to the working area if you do git restore minus minus stage. This is the difference between both of them. So let's say we do git add readme.txt, git commit, we do this is my third commit. Now because you have got your third commit, you do git status. There is nothing in the staging area, there is nothing in the working area. Now if you will try to do git restore minus minus stage readme.txt, currently let's see, readme has all 36 lines. If you press this, see, nothing changes, because once you committed, everything in your staging area moved to the new commit. So staging area is now clean, staging area is empty, so there is nothing to revert back to, right? This is how you will imagine what will be the output of the command by thinking about what changes are lying in which area of the code. Now if you want to very easily understand the difference between the working area, and staging area, you can understand it very easily using this example. So let's say you are in your university or school exams of mathematics. You have a sheet, you have an answer sheet. Okay, this answer sheet is the sheet that will be submitted to the invigilator. Okay, now let's say there is a math problem for which you have to do some rough work. So what do? In your sheet, either you take an extra sheet that is a rough sheet. Let's assume you take a rough sheet. A lot of people might have asked for rough sheet from the invigilator, right? Then let's say you are solving question number 1. So for question number 1, first of all, you try to do everything on the rough sheet, all of the calculations on the rough sheet. Now, let's say your calculation worked. Now you want to add it in your answer sheet. So currently this rough sheet is your working area, because whatever is there, currently it's not part of your actual examination sheet. That means currently whatever is there is not going to be submitted, right? This rough sheet is not submitted. Answer sheet is submitted. Answer sheet is your staging area. And what is the difference between working area and staging area? In staging area, whatever changes are there, they are going to be the part of the next version, or they are going to be submitted, something like that. So whatever changes you have in your rough sheet, if you want, you can bring them in your answer sheet. So let's say some changes you brought in the answer sheet. Now these changes are actually part of the staging area. Okay, cool. Now let's say you did question number 2. For question number 2, again, you did some rough work. Now this rough work is not going well and you are not able to solve question number 2. So this wrong rough work you are not going to copy in the staging area, right? Or in the answer sheet. What you are going to do, you are going to just discard. Okay, maybe this approach didn't work for question number 2. Let's try another approach. This approach also didn't work. Let's remove it. Let's try another approach. So technically what you are doing, you are adding data in the working directory and you are doing git restore on a file. On this working directory, you are doing git restore. So whatever was there, you are removing it never makes to the staging area, right? But now let's say your third approach on question number 2 worked. You are going to move it to the staging area. But then you realized, oh, I have copied everything of question number 2 in the answer sheet, but there was one pointer that I forgot including in the solution. That's why this solution is also wrong. So what you will do, you now want to remove this from your answer sheet to the rough sheet back, because now you have to do more calculations. So here, in order to do that, you will do git restore minus minus staged. Git restore minus minus staged. So what will happen? These changes will be gone from the answer sheet and they will be back in the rough sheet. Now you will include those extra parameters also, have your answer, and then you do git add, and those are again in your answer sheet. Once you do git commit, this answer sheet will be submitted to the invigilator. That means one version of your examination is actually gone. That's how things work between working area and staging area. So working area is technically a rough area. Until or unless you are sure that, okay, this thing works, you don't add it to the staging area. If you have already added in the staging area, this means that this piece of work which is in the staging area can go to the next possible version. But if still there is some problem, you can bring it back to the working area, make changes there, or maybe discard the changes altogether, and then add again in the staging area. Now let's say I did one more change. Let's say point number 12. We can say difference between git rm and git restore. Okay, let's say this is a file change. You can do git status and you will see there is something in the working directory. Okay, let's add it. Git add. Now those changes are in the staging area. This changes in the staging area. So generally you can see it in VS Code also. If VS Code is showing a green bar here, that means those are in the working area. If it doesn't show green bar, then changes are in the staging area. And let's say I add one more line answer. And now you do git status. And you can see we have some changes in the staging area, some changes in the working directory or the working area. Let me copy everything so that I don't lose anything. Now everyone knows if I do git restore, answer will be gone. If I do git restore minus minus staged, then point number 12 will come to the working area. Okay. What happens if I do git rm? If I do git rm readme.txt, okay, let me copy. If I do git rm readme.txt and press enter, can you see the following file has staged content from both file and the head. If you want to remove it, you need to forcefully remove it. So by default, Git knows that now you are not doing something correct. Git rm should not happen if you have something in the staging area. Okay, let's bring back the changes from the staging area. I'll do git restore this. Let's do git status. Now can you see there is nothing in the staging area, everything is in the working area. That means now everything is in my rough notebook or rough page. Okay, now if I do git rm, see, now this worked, and let's see what happened. Now technically you have not lost anything. See, you have not lost anything. If you do git status, then technically git rm has removed your whole file from the staging area and your dirty working area as well, and now it is untracked. So whenever you have to move a whole file back to the untracked area, then you use git rm. But if you have to only play with working directory and staging area and working directory and staging area, then you do git restore. Let me add it. So if you want to move the whole file back to the untracked state, then we do git rm. Otherwise, if we just want the changes, to be moved in working area or staging area, then we do git restore. Okay, So when you do git restore, it only manages the last changes. But if you do git rm, it moves the whole file to the untracked area. And what is the untracked area? Technically your working area. Now technically there is nothing in the staging area. This whole file is now gone, right? Now if you will do git add readme.txt, you do git status, right? And now you do git log. Let's see, we had 3 commits. Now you do git commit, press I, this is my 4th commit, escape colon wq. And now you do git log. Now this is your 4th commit, right? This is actually what is going to happen. And there is a very cool way to actually see what is the difference between 2 of the commits. For example, you have 2 commits, that means you have 2 versions. Now you want to see what is the difference between the 2 versions. That also you can very easily see. So there is something called as git diff. Okay, so what you need to do is you can take the commit id, first commit id, let me write it somewhere, then you can take the second commit id. Okay, let me write it. And now if you do git diff, use the first commit and use the second commit and press enter. Now you can see it is showing you what has changed, right? This line number 12, you can see this was diff this, no new line at the end of the file. This only works if the changes are in your staging area. So you can see all of these changes were previously not present and now they are present. So technically if you will just change the order of the IDs, let's say this is the previous ID and now this is the new ID, that is the latest commit. If latest commit you mention second, so now this is the actual change. That is, these all 4 lines were actually added, right? So in the last version already there was readme.txt, you played with it, you removed it from staging area, you removed it from working area, you did a lot of stuff, but at last when you actually committed, these are the code changes or the line changes, so you can even track them with a plus. I know this is not visually too much appealing, but when we will push all of this code to GitHub, all of these changes will be very visually seen, right? So this is how you can actually manage multiple states of your file and changes. Now let's say you made one small change, for example this. If we want to avoid opening a text editor like vim/nano to add commit message, we can use this following command. Okay, so currently what is happening is if you are doing git commit, it opens vim editor or nano editor in front of you, whatever is your system default. If you want to avoid it, let's see, currently if you will do git status, we have some working directory changes. I'll do git add readme.txt. And now if I want to see, let's say if do git status, see now we have changes in the staging area. Now if you want to commit and you don't want vim editor to open, but you want to directly give the commit message, what you can do is you can do git commit -m. So there is a flag that you can give -m. So after git commit, if you will do -m, it will not open vim editor or any editor in front of you. Then you can put a pair of double quotes and you can say this is my 5th commit. So if you want to put a commit message, you can do it like this, git commit -m, and whatever is your message, you can add it like this. Okay, inside double quotes you can add your message, your commit message. Commit messages are like, you might feel that why do you need a commit message? Commit messages are important to make sure that whatever is the version that you are actually tracking, that version actually has a detailed description of what actually happened in the corresponding version. That's why you want to put a corresponding commit message. Okay, so the moment you put it, you can see vim editor didn't open and you can just directly do git commit -m. If you do git log, then you can see first commit, second commit, third commit, fourth commit, and now 5th commit. So without opening the vim or nano editor, if you want to just directly commit by putting a message along with the command only, you can use git commit -m. This is also one cool thing that you can go for. Now, I already mentioned that GitHub is technically an open online tool available on the internet where you can collaborate and make repositories. So we just made a Git repository on the local. What you can do, you can directly make a Git repository on GitHub. How? Once you sign up to GitHub, you can see there will be a plus icon. Once you click on it, it says new repository. How do we used to make new repository in our local machines? When we had a folder and we do git init, used to initialize a new git repository. On GitHub, if you want to make directly a git repository, you can do a new repository like this. It will ask you for the repository name. So I'll say git tutorial. Okay, some name you can give. You want to make it public or private, that's your choice. And for the timing, let's just do, I'll not check anything, I'll not check add readme or something, I'll just do create repository. The moment you do create repository, you will get a bunch of commands. Now, why are these commands here? So let me tell you. Currently, you have a local repository or a local project that is just on your machine. You can make it available to maybe your local network. So all those computers which are maybe connected to your computer with a local network, maybe you can very easily share among them. But if you want to share this project to everyone all over the globe on the internet, then you need to make this repository live on the internet. So we have a local repository on our local machine and we have a GitHub repository. Now what we are going to do, we are going to connect these two repositories together. We are going to connect these two repositories together. So what we are doing is, let's say what they say. They ask us to make a readme file, for example, and then they ask us to do git init. That we have already done in our local repository. Git init we have done. Git add we have already done a file. One or two files we have added. One file we have added. Commit we have already made. So that is also done. We have bunch of commits. Git log. We have a bunch of commits. Git branch they are asking us to do. It's not mandatory to do git branching, right? So we'll come to the concept of branch. For the timing, very easily, if you want to understand branch, it's like parallel timelines for your same project or parallel realities of your same project. You can just assume like that. But there is a default branch always. That's the master branch. So you will get a master branch by default. Okay. So this git branch -m is to create a new branch. We will not go there. So this command doesn't need to be executed. And now there is a very interesting stuff. Git remote add origin, and then there is a URL. Now this is something very interesting. What is git remote, right? What is git remote? Git remote command helps you to actually connect one repository to any another repository, right? You can prepare direct links between two repositories. So your local repository, if you will execute this git remote command, it will link your local repository to this repository that we have as git tutorial, right? Currently this is a private repository. You can even make it a public repository. I'll change the settings. I'll show you how can you change the settings. But the git remote command, what it actually does is it helps you to create or maybe delete or maybe view connections between two repositories, right? And this, due to this git remote, we will be able to in real time access one repository from other or update one repository from the other repository. Everything we'll be able to do. So what we actually want to do is we want to like link our local repository to the GitHub repository, so that from the local repository we can push some changes or get or pull some changes in our local. So from our local we can push some changes to the GitHub repository, or if you want to download some changes from our GitHub repository to the local repository, we can do that. For that we are going to do actually git remote. So now by default, if you will click on git remote, just do git remote, nothing more, nothing less, it will not print anything. It will not print anything. Why? Because there is currently no connection between this repository and any other repository. Now there is something called as git remote add. When you do git remote add, then things start becoming interesting. Using git remote add, you actually create a new connection or create a new remote repository connection. then you can name this connection. So you can have multiple connections, so you can name every connection separately. So generally people name the connection as origin. So if you will ask someone that what is origin that you're writing everywhere, people won't be able to give you a concrete answer, because people just use the word origin. Instead origin, you can write anything here. You can write Sanket, you can write O1, O2, A3, anything you can write. It's just like a name of a remote connection. And then this is the link of the remote connection that you want to connect to, right? So git remote add will create a connection. This is the name of the connection using which you will be able to identify the connection. And this is the URL where you have to make the connection. Once you have added the connection, then you can use the name of this connection like origin. Here you can see git push origin, something they are doing. So they are using the name of the origin to actually do a command. So from your local repository, if you want to call this link for, let's say, uploading some content or downloading some changes, you will just directly use this name. So origin is just like the name of the remote that you have added. You can even remove some remotes by doing git remote rm. You can add a remote by doing git remote add. Okay. So let me copy this command, git remote add, and this URL, paste. The moment I enter it, you can see no prompt at all. But if you do now git remote, you can see you have a remote origin because we just added a remote with the name origin, and this is the link. Now, due to this git remote origin, we have prepared a connection between our local computer's Git repository to the GitHub Git repository. Now, if you want to upload changes from your local repository to the GitHub repository, you can do git push, right? And then you can mention the name of the remote origin. And then you can mention the name of the branch. Branching we will discuss, but as I already told you, there's a default branch called as master. You can upload it there. Git push origin master. If you press enter, you can see it's enumerating stuff, delta compression, something it will do for uploading. And then it has uploaded everything. You come back to GitHub and just do one refresh. And you can see we have a readme.txt file, right? Those instructions are gone. GitHub, if you have a readme.txt file or readme.md file, GitHub automatically displays also that. That's the property of GitHub. Here you can see all of your 5 commits. You can go to click on 5 commits. Let me show you where. In the left corner, see 5 commits. Click on 5 commits. You'll be able to see 5 commits. Some initial of your commit ID. If you will click on any commit, you can see what changes we did. So the git diff changes that we were able to see from the last commit to the next commit. See, from the last commit to the next commit, you are actually able to see very pleasingly on GitHub. And you can see any commit. Like every commit is now your version. This was our first version. This was our next version. This was our next version, and so on. Right. So this is how you can actually watch it. And currently this is a private repository. So if you want to convert your public repository to a private or private to public, you go to settings. You can see settings button here. Then in general, scroll down and you will see danger zone, change repository visibility. You click on change visibility, change to public. I want to make this public, make this repository public. It will ask for your password. And boom, done. Now this is, you can see, a public repository. Now anyone can come to my GitHub and go to my repositories and we'll be able to see this Git tutorial repository, right? And that's how we do it. So now see, in line number 14, you git status. See, there are some changes, right? In line number 14, we added this git commit, this command we added. See, this command is not coming up, and we'll add some more changes. So 15, git remote. What is git remote? List down all the remote connection names. What is a remote connection? It helps you to link to Git repositories for uploading and downloading changes from each other. Okay. Then you can do git remote add name of remote connection, and then link of the remote. Okay, this command helps us to add a new link to the remote repo. Remote, why do you call it remote? Remote means something which is not present immediately with us, it is present somewhere else. That's what remote is, like remote jobs. So remote, that's like somewhere else. So add a new link to the remote repo and give a name to it. Okay, there is a command that you can do, git remote rn and name of remote. This command deletes remote connection, and then there is something called as git remote rename. So you can give old name and you can give new name. Okay, this command renames the remote connection. Just a note, the name of the remote connection is always used to establish communication between the repos. So you can see a bunch of changes we have. Now what all you have to do, you will add the changes of the file, git add. I'll do git commit -m. This is my 6th commit. Git push origin master. Now the moment you did commit, you committed a new version in your local git repository, and when you did push, then in the remote connection you have uploaded all of the new changes. The moment you just refresh, you can see you have 6 commits now, and all of the new details are also here. That's the best part, right? And one more thing that I would like to do, I will rename this .txt file to make it a markdown. Okay, because in markdown you will see syntactical updates. I'll do git add again. Sorry, my bad. Git status. So now you can see git readme.txt has been considered as deleted, and there is a new file readme.md. So I'll do git add readme.md, git commit -m. This is my 7th commit. Technically, you should write more meaningful names. I'll tell you how to write good meaningful names also. Git push origin master. If now you refresh, now technically you will see a bit of syntax highlighting also, because now readme.txt is gone and readme.md is here. If you go to your last 7th commit, right, you can see you just renamed the file without any changes from .txt to .md. So it also shows you that, right? So let's go back, and that's how you can actually establish connection between two repositories. Now let's say that maybe currently you made some changes. Okay, so let's add one more command. So let's say if you have to add multiple files together to the staging area, you can do git add, and then you can write every file name, file 1, file 2, file 3, and so on. This command will add multiple file changes together in the staging area. And let's say you don't, if you have, let's say, 15 files and you don't want to add every file name manually, then you can do something like git add dot. What git add dot will do is, this command will add all files from working repo to staging area. Let's see. So currently you do git status, you have untracked files in the working area, and you have a staged file with untracked changes in the working area. If you do git add dot and you do git status, you can see everything, all of the 2 files are now in the staging area. So generally this dot is technically a reference where at any point of time, if you want to refer to all of the files in the current repository, you can technically do that. This kind of a dot base syntax is used in multiple commands. So git add dot for the simplest meaning, you can say that in current folder wherever you are, if you want to add all of the files, then you can technically do that. Then you can do a git commit, and this is my 8th commit. Git push. That's it. So this is how you can add if you want multiple files, or if you want to just add all of the files, you can do that. Now let's say that you have a remote repo, right? And let's say multiple people are collaborating together on this remote repo. Currently, I'm only the one who is committing, but maybe I have few more team members, and they made some changes. So, for example, let's say they add a full stop here. Okay, so you can directly update files from GitHub also. You can say edit file, and you can create a commit. So you can write a commit message. This is the 9th commit, and you can describe your commit changes. You click on commit. What will happen, because now you are already on GitHub, so when you do commit on GitHub, it directly pushes also, like of course it is obvious. But now technically you have 9 commits here. Now let's see, if you do git log on your local repository, your last commit is the 8th commit, because your local machine doesn't know about the changes that happened to this remote repository. So if you want to download the latest changes in your remote repository, you need to do git pull. Pull means you're going to download a bunch of changes. You need to mention the remote origin, and you need to mention the branch. For the timing, until unless I mention you about different branches, assume that every time you have to do master, when we'll cover the concept of branches, you will understand branches meaning. So git pull origin master, press enter, and you can see it downloaded a bunch of stuff. If you do git log, you can see now you also have 9th commit in your local machine, right? So that's how things will work, where your other team members will also upload their code, and daily you will try to do a git pull, and you will download all of their changes. So let me even add this command. Okay, so this is going to download the latest changes from the branch of the mentioned remote in your local repository. Okay, this is going to wait. Now let's do git add all, git commit -m. This is my 10th commit technically. We'll do git pull everything. See, now if I try to download, there is nothing that has changed there, so it says already up to date. And I do git push, refresh. Now you have 10 commits. So generally it's a recommended practice to do, like there is a recommended practice to do. What is a recommended practice? Generally people try to make changes, do git add file by file, then do git commit. Once you have done git commit, try to first do git pull and then do git push, so that your push never fails. And if there is any changes that has to be downloaded, you first download that, because you don't want to, like, I'll talk about this branching and commit system, that how can someone race forward from you, or how can you be very how you can have very old changes and all. So you don't want to hamper that flow. So generally it's a recommended practice to always make code changes, do git add, git commit, first do a git pull and then do a git push. Generally a lot of people, what they do when they start working in the morning, then first thing that they do is do a git pull on their local machine, so that till the time rest of the thing starts, they have the latest download copy of the work. So this is a general recommended practice that you can technically follow. So let's say if you want to add multiple team members who can contribute to your git repo, there is an option of collaborators. You can add people directly here, and they will be having access to your origin and everything. So that is something that you can do. Now technically if you have some changes in your working directory and you try to do git pull, see, everything works. Let's try to make a change directly on GitHub. Let's add something in the new.txt, or let's add something in readme.md. Okay, Let's add a full stop somewhere. Full stop. Okay. My 11th commit changes. Okay. Now there are a bunch of changes. If you do git pull origin master, you can see the changes now aborted. Why? Because we are having a local changes in the following files readme.md. So there are few changes which are not in the staging area, right? So please commit your changes. So not even in the state. For example, if I do git add readme and I do git pull, still it aborts because your working directory should be clean, your staging area should be clean. Then only you can pull the changes. So either you need to commit them or you need to stash them. I'll talk about stashing. It's kind of like a safe locker that you have with Git. Okay, so let's commit it. Git commit -m. This is my another commit. Now if you do git pull, you can see now there is something called as merge conflict that has occurred. Let's see what happened. So now somebody actually made changes to the code, right, in the same file where we were also trying to make the code changes, right? And we did something kind of like a bad practice because we were having local working repository changes, we tried to pull and a bunch of stuff happened. So this is something that is a very common scenario. This happens and the one who is having the merge conflict, they need to resolve it. VS Code gives you a very cool way to resolve it. You can actually see, for example, if you go back, you can see they ask to keep your current change. So whatever was your local change, you can keep that. Whatever is the incoming change, you can keep that. See, so this incoming change is this empty line. You can accept both the changes or you can compare the changes. So you can compare the changes that, okay, this is something that you are doing, they don't have it. What do you want to do? Okay. You can even resolve in merge editor. You can see line by line, it will show you that what actually will happen. So this is the incoming change. This is the current change. What will happen if you do accept incoming changes? This will happen, right? If you do accept combination, this will happen. So their change and your change will be merged. If you want to ignore, then this will be ignored, right? If you do accept current, see this change will come. So you have to resolve this merge conflict, right? And you can click on complete merge. Okay. When you click on complete merge, it will show you to create a new commit. Whenever you actually complete the merge, you have to create a commit, right? You can even see automatic merge conflict failed. So using VS Code, you can resolve merge conflicts. You can just commit it, right? And I have not configured my GitHub, VS Code. So now I need to do a manual commit. So git status, you can see, and we'll do git commit -m resolved merge conflict. Okay. And now you can do git pull again. You can see now everything is up to date. Now you can do git push. So your changes will go and everything and everyone will be happy. Your changes are also here. So there can be a case that if multiple people are contributing to the same file code, then there can merge conflict occur. For example, they also trying to do some change, you are also trying to do some change. Which change Git should pick, it is not able to decide. Then you have to manually resolve it. This resolution you can do using this merge conflict. I believe VS Code's tool is very good with respect to any other editors, and manually resolving the commit might be a bit hassle. So I recommend you to resolve the incoming changes and current changes decision using VS Code. And then if you have configured VS Code for Git, you can directly make a commit or you can just come here and make a commit here. That's all that you have to do. So if you want to mimic this again, let's try to do it. Let's make another change. Okay. For example, merge conflicts are a very common scenario. Okay. I will create this commit. Okay. If you will not write any commit message, it will directly just say update and file name. Okay. Now I will do some changes here also before pulling. Merge conflicts can occur if multiple people try to make changes to the same file and then collaborate. Okay, cool. Now let's see. If I will try to do git add, then I'll try to do git commit. Added data about merge conflict. And I do git pull. Let's see if it is able to resolve or not. See, again a merge conflict came. Why? Because in the same file, last line you are trying to make changes. In the GitHub repo, the change is already there, but in the local it was not, and you made the change. And that's how you come to the same situation. So what is the current change? See, this is the one that I wrote in my local system, right? And the incoming change that is coming from GitHub is this. So if you have to manually resolve it, you can just, so these angle brackets and head, you need to remove this along with this line and these angle brackets also. This is one way to resolve. So you are manually removing extra piece of code. This can be a bit of hassle. So that's why you can go to resolve in merge editor, or you can just do directly here. You can just do directly here, or you can go to resolve in merge editor, and then you can see how your changes will look like. If you will accept a combination, then this will be first, this will be second. If you do command Z, and if you do a combination of incoming first, then incoming will be first, then your code changes will be there. Whatever works for you, you do a complete merge, right? Do a git status. You again do a git commit of resolved merge conflict. Now you do git pull. Everything will be up to date. Git push. That's how you can actually resolve merge conflicts.
So I hope you guys really enjoyed the Git lecture. I really hope that it was fruitful for you. There are going to be more parts that we are going to come up in the Git series. There will be at least 2 to 3 more lectures that we are going to post on the same YouTube channel. So don't forget to subscribe to the channel. And if you have not yet visited algocamp.io, I would highly recommend you guys to do that. There are some cool and awesome courses that we are going to launch with pretty reasonable costing around DSA in Java, backend in Java, and all. So you can see this course is a complete end-to-end Java course where you're going to start everything from core Java to advanced Java, learning backend development in Java, data structures and algorithms in Java, system design, low-level design, high-level design, everything end-to-end. It's a hybrid course, 60% live classes, 40% recorded, or mix and match of that. Right. So don't forget to check out algocamp.io and do check out all other courses that we have launched. For example, there are a bunch of courses around data structures and algorithms in JavaScript, also coding interview preparation, etc. So do check out algocamp.io. And if you really liked this particular lecture, don't forget to like the video and drop your thoughts in the comment section. What more lectures do you want me to put on this particular channel? That being said, let's just wrap this video here. It was really exciting to discuss all of these things around Git. I'll see you in the part 2 of the Git series. Till then, take care, guys. Bye bye. I'm Sanket Singh, signing off.